Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will discuss about the overview of the course, and that is evaluation of textile material, the analytical approaches. In the last class we have discussed the few basic ideas on textile evaluation. Few terms we have used. Now the entire course which we are going to discuss here. So today I'll give you the overview. So the module 2 will discuss the analytical approach to sampling of textile material. So here we will actually use the sampling. In sampling, what are the analytical approaches we will be using, that we will discuss. So first we will discuss the meaning of sampling. Basically, sample means the small portion of the population. So why do you need this sample, and everything we will discuss in this module. Next is that is aim of sampling. Why do you need sampling? Then factors govern sampling method, that is your like example, if you have a small quantity of fiber, this much quantity of fiber I have got, and I want to test the fiber length or fiber strength. So I'll sample differently than if I have say 100 bales of fibers. So for that is the governing method will be different. Similarly, I have got one bobbin of yarn. I want to test the yarn linear density or yarn strength. So for that, my sampling technique will be different than if I have say 1 ton yarn cone. So this governing factors we will discuss there. Then types of sampling. Different types of samplings are there. We will discuss the classification like random sampling, systematic sampling. So all these details we will discuss there. Different terms used for sampling. So we will use the different terms: a lot, laboratory sample, test specimen. So all these things, what are their meaning, and why do you need this type of terms, that we will discuss. Sampling stages of textile materials, like where we can sample from fiber, from yarn, from fabric, and say fiber from bale, fiber from sliver, or fiber from say yarn. So this type of sampling are different. So from bale, suppose you want to test the fiber length from the bale. So the sampling technique will be entirely different than if we want to test the fiber length from the say card sliver. So that sampling that we will discuss in detail. Then few statistical terms, the concept of critical difference that we will discuss. Fiber sampling from bulk. Now coming to then we will discuss the sampling methods. Sampling methods. So fiber sampling from the bulk. How to sample fibers from bulk. Basically, it's a for cotton is in bale form and wool also in bale form. So their sampling techniques will be entirely different, because cotton you can simply take out, because cotton is not, there is no grease, but wool has got grease content, and wool, taking out wool lump, wool actually tuft, is not that simple. It's a very solid material. It's a very compact material. So that for that we need different types of sampling. So like fiber sampling from tuft, sliver, and roving yarn, their sampling techniques will be different. So fiber sampling from sliver and fiber sampling from the yarn will be entirely different, or from this open tuft. This will be the difference that we will discuss. Then yarn sampling. After fiber sampling, then yarn sampling, like yarn sampling from the bobbin, yarn sampling from cone, yarn sampling from fabric. So there are different types of yarn sampling. Then fabric sampling. So there are fabric sampling for, say, strength testing. So the techniques are different that we will discuss here. Then sample size. So how to judge the sample size. Suppose I want to test the yarn count. So how many data we have to take? How many readings we have to take? So I want to test the fiber length. How many data we have to test? How many times we have to test so that it is statistically significant? So this number of tests, that is sample size, it's important, and this here will actually do the analytical approach. You use the analytical approach to know the number of tests required. So for that we will require the statistical technique that we will discuss, and test of significance. Now test of significance means what? Like whether the result is significantly different from the target is there or not. Like our target, this is suppose 30 count here. 30 count. Now after testing say number of samples, say 10 sample or 20 sample, we have got this sample, say for 30 NE, here we are getting say 29.5 NE. So our target is say NE yarn. But after testing, say we have followed the statistical technique and we have tested this is getting 29.2 NE. So this is coarser. This yarn we are getting coarser. Now whether we have to adjust the machine, we have to adjust the draft or not, for that we have to do some statistical analysis. This is called significance testing. Like it's very simple to stop the machine and adjust it little bit, making it little bit finer, and we are getting say 29.5. Again we are not satisfied, again we have stopped the machine, we are getting say 29.8. So this will go on, and exactly reaching is not possible. Once you will reach, then again same next time it is gone. So this will actually waste your time and your productivity. It's not the good idea to stop the machine. Now through significance test we will come to know whether you have to stop the machine or not. whether it's going out of our limit or not, that will stop. And if it's a significantly different, then we'll stop. Otherwise, we will let it go. Next is the control chart. Control chart is one that we will discuss later. So, where pictorially you will come to know your quality stand, quality, whether this your quality, like yarn count, yarn linear density. You will come throughout the say month, throughout the month or throughout the year, how you are performing. That you will get in a control chart. So that we will discuss. And all these things we will do through the practical statistics. One thing we must know here, we will not be doing the statistics class, but we will use some practical statistics just to know our sampling, or whether the test data is actually within the statistical limit, within the limit or not. That much we will do. Okay. And next module, module 3 here, we'll discuss the fiber length, where we will not concentrate ourselves within the fiber length measurement, but we will do the statistical approach of measurement, and so that the data analysis is simple, where different types of parameter expressions, okay, of fiber length, okay, related to the fiber length characteristics, meaning and relative importance of all this your expression, like different types of fiber length related characteristics is the, say, span length. What is the meaning of span length? Okay, say 2.5% span length and 50% span length. What is the, like, uniformity ratio? What is the meaning of uniformity ratio? All these things we will be doing, and methods of measurement we will just touch up. We will not go in detail the methods of measurement, like hand stapling method, Shardley photoelectric stapler, comb shotter, single fiber length measurement, length measurement by weighing method, clamped tapped method, with a fiber length diagram for wool. So all this we will discuss, and fibrogram method. But our main focus will be the analytical approach, how to analyze all this test data. Okay. Wool fiber length measurement, okay, but it's called almeter, okay, where automated wool fiber length measurement systems. Then module 4 is that fiber fineness and maturity, where we will discuss the importance of fiber fineness, methods of measurement. Different methods are there for gravimetric methods, microscopic method, airflow method, optical fiber diameter analysis, and fiber diameter analyzer. So all these methods will be discussed, but the data coming out from all this test and how to analyze, and through the numerical, and what are the interpretations of this data, that we will discuss here. Okay. Although we will discuss in short the methods of measurement, but the main focus here is the analytical approach of this method. Vibration methods, like how to test we know, but how to analyze the data, that we will discuss here. Okay. Then concept of maturity of cotton, okay, parameters to express the degree of maturity, like what is the meaning of degree of thickening. Okay, so it's called degree of cell wall thickening or degree of thickening, maturity ratio, then maturity count. So all these parameters what are their implications, this we will discuss. Methods of measurements of this maturity, a caustic soda method and microscopic method, where we use the caustic soda. In our lab we do caustic soda to swell the fiber, particularly cotton. Like one should remember, the maturity terms we only deal with the cotton. Okay, we don't deal with, definitely we will not deal with the synthetic fiber, man-made fiber, but for even for other natural fiber like animal fiber, like wool, like plant fiber like jute and different other fiber, the term is not that significantly important, but for cotton it's important because it actually maturity directly impact the quality of the product. So that's why it's very important, like caustic soda and microscopic method, where we measure the swelling characteristics and the width of the lumen and the cell wall width, that we measure, and with that there is a relationship. We can predict the maturity content. Then double compression method we will discuss, where we compress the fiber in at different compression level and measure the airflow. It's similar to the airflow method, and through some regression equation we can predict the maturity. Caustic air method. Caustic air method is little bit different from the caustic soda method. In caustic air method, what is happening, when we treat with the caustic soda, it gets swelled, and then before swelling, before caustic treatment and after caustic treatment, we measure the airflow, and depending on the maturity level, the airflow will change. So that is their caustic. High volume instrument method. High volume instrument method, the maturity is actually tested by mainly by fineness. Actually, there is no method. Advanced fiber information system, AFIS method. This is very good. It's where this is the only method where we can measure the degree of thickening, like which is the ratio of the total perimeter of the fabric fiber by the divided by the perimeter of the circle of the same cross section, same fiber. So that we will discuss. Image processing technique is also there, near infrared, but our main focus will be the analytical approach here. Then moisture in textile material. So textile material has got directly affected by the moisture. Okay, so moisture is important. When it absorbs moisture, it is not only its mass changes but also its characteristics changes. So moisture has got direct impact on textile material. So moisture regain and moisture content concept we will discuss. Regain means what? You have a dry material, completely dry material, then how much moisture it is taking. So I am just drying it, completely drying, no moisture is there. Now I am putting it in this room where say 65% relative humidity is there, whatever maybe, and then after keeping for certain time, say 1 day, a full day, and it absorbs, keeps on absorbing moisture. That means how much it's regaining, it's gaining. It was moisture was there, I have removed the moisture and it's regaining again. So that's how it's called moisture regain. Moisture regain, that where that means our reference is the geo moisture. zero moisture. That means the denominator will be zero with the zero moisture. So that we will discuss there. And moisture content means the material is there at whatever stage is there, and we are trying to remove the moisture. We are now trying to drive out the moisture. That means this material is with moisture. Now, how much moisture present I am trying to see. That's why it's called moisture content, where denominator will be the total weight, including moisture. So that's a basic difference. Moisture regain and moisture content should not be, we should not get confused. Regain means zero moisture, I made it zero moisture, and how much it's regaining. So that's why denominator will always be the zero moisture content. Atmospheric condition and relative humidity. The understanding of atmospheric condition is very, very important. Now I'll just explain a little bit. Now, why do we need to use relative humidity? Why do we use relative humidity? Why not the absolute humidity? So, what is called absolute humidity? Suppose this is a enclosed chamber, okay, of say x cubic meter, enclosed chamber. Now here these are the moisture vapor content, and vapor content, if you see that here total mass of the vapor content is say y gram, and the temperature here is say 25 degrees Celsius. 25 degrees Celsius. In this room it is 25 degrees Celsius, and here so x cubic meter is the total volume of this room, and say y gram is that. Now here the absolute humidity will be y by x this is the absolute humidity, gram per cubic meter, humidity content, moisture content in there. Now here it's there. Okay, now I am certain opening I am making certain opening. What I am doing here, I am pumping certain moisture vapor. I am allowing some moisture vapor to come. Okay, but kept temperature constant, and I have added a gram moisture for say within a minute. I have added a gram moisture and then again closed it. What will be the absolute humidity? It will be y plus a by x. Absolute humidity has changed. Now I am keeping on pumping it. Now it is going and going, and it is at a z gram. After z gram of entering, it has got certain limit, and then what will happen? It will start dripping. After up to Z gram it is holding. Then after that, when it's crossing the Z, then the air is not able to hold that much moisture. It is actually that situation is called saturated. So what is the saturated absolute humidity? Y plus Z by X. That is the saturated humidity at 25 degrees Celsius. Saturated humidity. Now I am increasing the temperature again. 25, I am making it say 40 degrees Celsius. Y plus Z, now closed it. Now I am increasing the temperature. What will happen here? Then this vapor particles will have some energy, will try to move. Then what will happen? You can pump in some additional A also, say K gram, before it gets saturated again. So saturated humidity at 40 degrees Celsius will be Y plus Z plus K by X. That is the at 40 degrees Celsius. This is at 40 degrees Celsius. Okay, this will be at 25 degrees Celsius. Saturated humidity at. That means your saturation is changing. Saturation is changing. So here Y plus Z was there, and here at Y plus Z plus K. Now I am keeping this material in saturated condition. Saturated condition with this material here at 25 degrees Celsius. I am keeping another room at 45 degrees Celsius. I am keeping. Now that means this is exposed with higher humidity at 40 degrees Celsius. Okay, that means it will absorb more, although it is saturated. Although it is saturated, same saturation level, but 40 degrees Celsius it's absorbing more moisture. So that what does it mean? That means something is there, the temperature is playing some role. That means absolute humidity is not that important. Its temperature is also important. Okay. So that's how. Now here again come back to the 25 degrees Celsius. 25 degrees Celsius it was Y grams. Okay, absolute humidity. And what is the saturated humidity? This. This ratio is called relative humidity. This ratio of absolute humidity in that condition and absolute humidity in the saturated condition it's called relative humidity, but relative humidity at that temperature. Now let us see in other way. At 25 degrees Celsius, it was, say, X gram was the weight of the moisture. Now Y by X, Y gram, X was the volume, X cubic meter, Y gram was the relative. So, and here saturation was that at that temperature, what is the saturation? Say X, Y, we are getting Z, so Y plus Z was the saturation. So Y, let us keep the data, okay, that will be better. So initially it is a 5 gram material, that is your moisture was there, and after say additional 5 gram it is getting saturated, so 10 gram. So 10 gram was the saturation humidity. Okay, so what was the relative humidity here? 5 by 10 to 100. RH percent was 50%. Now we are here, it's a 5 gram material is there, but if we increase the temperature, the saturation will not be 10 grams, saturation will be more than 10 gram. So saturation say becoming 20 grams, suppose, because its energy has increased, it will, saturation has become 20 gram. So although absolute humidity is same, absolute humidity is 5 gram per cubic meter, say, but relative humidity is changed to 5 by 20. 25% again. 25%. So absolute humidity is not that important. Your relative humidity, that will actually affect the characteristics of the material. Okay, so that with that concept we will do some numerical statistical analysis, or then hysteresis effect. Hysteresis effect we will discuss. So any hysteresis means you change the path, or you you deviate from initial zone, and then if you are trying to come back to that zone again, so there will be certain resistance. This is called hysteresis. That we will discuss in detail. Measurement of moisture, how to measure the moisture we will discuss. Then correct inverse weight, it's also very important aspect. Correct inverse weight is the weight when you are sending a material to your customer, or you are buying material, you are paying for the material, not for the water, moisture. So, and also at the same, as this material, hygroscopic material, you don't have any control over the, provided you are not doing any mischief, you are not adding some water or something. Suppose at different condition in the shade, it's not always easy to maintain the exact humidity. So humidity, the moisture regain will be different, maybe little bit vary. But you are paying, as you are paying for material, and at the same time you cannot have zero moisture. So there has to be certain understanding. So that's why there are internationally accepted regain level is there, and you have to correct your, suppose you are, we have produced, the standard accepted is 8.5% relative moisture regain for cotton is accepted, and what we have produced with a 10 relative humidity, 10 moisture regain. So accordingly I have to correct the invoice weight to bring it to 8.5% level. If it is dry, then I have to increase the correct invoice weight, so that the pricing is done. Factors affecting the moisture regain we will discuss, moisture and fiber properties we will discuss there. Then coming to the yarn linear density, which is very important, and analytical approaches we will do, direct and indirect systems we will discuss, and conversion of linear densities of different systems, which is very important. So direct system to indirect, indirect to direct system, and linear density of folded yarn, that will discuss methods of measurement of yarn linear density. Then next module, module 7, is the yarn twist analysis, analytical approach. We will discuss in the twist, the effect of twist in staple yarn, that we will discuss, because twist is very important. First thing is that without twist we cannot get the strength or staple yarn, because of the twist provides the cohesion, fiber to fiber cohesion. But at the same time, twist, with the increase in twist angle, the contribution of fiber strength towards the yarn strength reduces. Okay, so that this effect we will discuss. Then application of yarn twist. So yarn twist we can use for different purposes, like your shadow effect, and maybe some different types of crepe effect. We use the twist, change the twist level. What is the meaning of twist multiplier? So this we will discuss, twist TPI and twist multiplier. This part we will discuss measurement of twist of single yarn and plied yarn, and related numericals we will do. Then evenness characteristics. So evenness means your not only the mass evenness, it may be the evenness of fiber yarn diameter, maybe the twist evenness, twist variation. So there are different types of irregularities. So expression of yarn irregularity is there. That is normally we use in terms of percent, not the in absolute value, like percent mean deviation, which is in U percent, like CB percent. We'll discuss detail. Another important aspect is the limit irregularity. Now, concept of limit irregularity is that the existing best quality of raw material, best practice, if we adopt, we take the machine with a defect-free machine without any vibration, best machine we take, and then we are producing a material with a certain irregularity. That is called limit irregularity. We cannot produce better than that with ideal condition, which is called limit irregularity. But we cannot always achieve, we cannot achieve the ideal condition. There will be some deviation, machine will have some deviation, and that deviation is expressed in terms of index of irregularity, the ratio of actual yarn or actual irregularity and the limit irregularity is known as the index irregularity, that we will discuss, we will with the different numerical we will use. Then addition and reduction of irregularity, like every one thumb rule is that any production where stretching takes place, that means you are adding to the irregularity, and where doubling takes place, that means you are reducing the irregularity. Like in draw frame, first we double at the back, so 8 doubling or 6 doubling we do. In this stage we are actually reducing the irregularity, but after that when we stretch, that means we are adding the irregularity. So this concept we will do through the numerical. Okay. Variance length curve, the concept we will discuss in detail. Causes and effects of irregularity, and variance length curves are of two types. One is between length curve and one is within length curve. This concept we will discuss, and related numerical discuss. How to interpret the variance length curve, causes and effects of irregularity, and classification of random and periodic variation, that we will discuss. Random variation is mainly due to the raw material, mainly fiber, and periodic variation is mainly due to the machine defect, okay, machine component defect, maybe pinion, maybe roller eccentricity, that is there. And measurement of data evenness, how to measure the, and data analysis, this we will discuss. Okay. And yarn fault classification, so where we will discuss the uniformity or unevenness and yarn fault, or irregularity and yarn fault, what are the differences, this part we will discuss there. Okay. Then transmission characteristics. Transmission characteristics are of different types. Okay. One is that air transmission, then moisture transmission, moisture in liquid form and in the vapor form, and heat transmission. So this all we will discuss. The liquid transmission is again of two types of wetting and wicking. So vertical wicking, in plane wicking. So this all we will discuss here. Then moisture vapor transmission, heat transmission, and related numerical we will all discuss here. Okay. Normal condition and extreme condition. Mechanical characteristics comes where we will test all the mechanical like fiber strength of fiber, tensile testing terminologies we will discuss, factors affecting the tensile test results will be discussed. The principle of constant rate of elongation, constant rate of loading, and constant rate of traverse, this will be discussed. And the people get confused. Why the first question is that why do we have three different types of testing when we can have only one UTM where constant rate of elongation is there? What is the implication of constant rate of loading? Why do you use constant rate of loading? Why do you use constant rate of traverse? So these are all we will discuss. Okay. Tensile testing methods, fiber testing methods, fibers in bundle form and single fiber form, then yarn testing, fabric testing, all testing methods we will discuss in tensile condition. Then coming to the towards the mechanical testing, that is tear testings, factors affecting the tear testing, tear testing of fabric, different types of tear testing, the single rib tear testing, which is called tongue tear testing, then double rib tear test, then wing rib tear testing. Why do you use the different types of testing and their element of tear testing and related numericals we will try to see. Then bursting strength testing, basic understanding of the bursting, what are the application of bursting strength, this will discuss. Different types of bursting testing, like your diaphragm type of testing and ball bursting testing, what are the limitations we'll use. Abrasion and peeling, basic understanding, different types of peeling testing and abrasion testing, measurement of abrasion, and what are the factors which affect the abrasion testing. Okay. Then low stress mechanical characteristics, which is very important, particularly for apparel testing. So low stress mechanical characteristics is not for technical textiles, but for apparel textiles or home furnishing, it's very important. And there is bending, shear, drape, all this will be used. So another the method is it's a combination which is called Kawabata evaluation system for fabric, KESF, where number of parameters are tested there are 4 different modules: KESF 1, KESF 2, 3 and 4. Similarly, fabric assurance by simple testing, which is called FAST, it has also got 3 modules and 1 test methods like FAST 1, 2, 3 and FAST 4, which is a dimensional stability, which is not an instrument, which is by the test method. And composite testing also will discuss different an analytical approach. So why composite, what are the classification of composite? So we will try to give basic understanding of composite. Okay, so here different aspects will be discussed and related numericals also will discuss, how to calculate the void content or maybe fiber content. This all we will discuss. And then geotextile is also important. We have in textile here it's not possible to cover entire gamut, so we have taken geotextile and composite, because here the applications and testing are in different types of tests are required. So that's why we have taken geotextile and composite here. But there are many other technical textiles which actually can be tested within this all these parameters. Types of geotextile, function of geotextile, evaluation and hydraulic properties of geotextiles, like liquid transmission, in-plane transmission, that we will discuss. Okay, and that's all about the introduction and overview of the subject. And we will start with the module 2, which is sampling and the practical statistics in the next class. Okay, thank you then.